Section 1. Introduction. A holistic view of software quality. In the world of software development, quality reigns supreme. But how do we define and measure something as multifaceted as software quality? Enter the Factor Criteria Metrics or FCM model. By dissecting software quality into manageable components, the FCM model empowers developers to gain a comprehensive understanding of their creations and identify areas for improvement. These attributes extend beyond mere functionality to encompass aspects such as usability, reliability, performance, and maintainability. The FCM model provides a roadmap for navigating this intricate landscape by breaking down the abstract concept of quality into concrete, measurable elements. This systematic approach enables development teams to make informed decisions throughout the software development lifecycle, from initial design to final deployment. By explicitly defining the factors that contribute to a positive user experience, the FCM model ensures that development efforts are aligned with what matters most. This user-centric approach leads to software that is not only functional, but also intuitive, efficient, and enjoyable to use. In the following sections, we will delve deeper into the components of the FCM model, exploring how it can be applied to real-world software development projects to deliver exceptional user experiences. Section 2. Unpacking the FCM model. Factors, criteria, and metrics. The FCM model derives its name from its three core components: factors, criteria, and metrics. These components work in harmony to provide a comprehensive framework for evaluating software quality. Factors represent the high-level attributes that contribute to the overall quality of a software product, such as usability, reliability, and performance. Criteria, on the other hand, are more specific characteristics that define each factor. For instance, the factor of usability might be defined by criteria such as ease of learning, efficiency of use, and user satisfaction. Finally, metrics provide quantifiable measures for assessing each criterion. Think of the FCM model as a hierarchical structure. At the top level, we have the overarching factors that represent the key aspects of software quality. Each factor is then broken down into a set of criteria that provide a more granular definition of what constitutes quality in that particular area. Finally, each criterion is associated with one or more metrics that allow us to measure and track progress towards achieving the desired level of quality. This hierarchical structure provides a clear and logical framework for understanding and evaluating software quality. By breaking down software quality into factors, criteria, and metrics, the FCM model provides a practical roadmap for achieving software excellence. Section 3. Factors. The cornerstones of evaluation. Factors, the building blocks of the FCM model, represent the high-level qualities that collectively define a software's overall quality. These are the non-negotiable attributes that determine whether a software product is deemed successful or falls short of expectations. While the specific factors considered may vary depending on the nature and purpose of the software, common examples include functionality, reliability, usability, efficiency, maintainability, and portability. Each of these factors plays a crucial role in shaping the user experience and determining the overall value of the software. Functionality, as the term suggests, refers to the software's ability to fulfill its intended purpose. This encompasses the completeness of features, their correctness, and their appropriateness for the target users. A software application with excellent functionality performs its tasks accurately, efficiently, and in accordance with user expectations. Reliability, on the other hand, focuses on the software's consistency and dependability. A reliable software application performs as expected consistently over time, without unexpected failures or errors. Usability pertains to the ease with which users can interact with the software. This encompasses aspects such as the intuitiveness of the user interface, the clarity of error messages, and the overall learnability of the system. Software with high usability empowers users to achieve their goals efficiently and effectively without unnecessary frustration. By carefully considering and addressing each of these factors, development teams can ensure that their software products meet the diverse needs of users and deliver a truly exceptional user experience. Section 4. Delving deeper criteria and their significance. While factors provide a high-level overview of software quality attributes, criteria delve deeper, providing specific characteristics that define each factor. These criteria serve as concrete benchmarks against which software can be evaluated. For instance, under the factor of usability, we might define criteria such as learnability, efficiency, memorability, errors, and satisfaction. Each of these criteria contributes to the overall usability of the software and can be further analyzed and measured. Learnability focuses on how easily first-time users can learn to use the software. Efficiency, as it pertains to usability, refers to how quickly users can perform tasks once they have learned how to use the software. Memorability assesses how easily users can remember how to use the software after a period of not using it. The errors criterion focuses on the number and severity of errors users encounter while using the software, as well as how easily they can recover from those errors. By carefully defining and evaluating these criteria, development teams can gain a more nuanced understanding of the factors that contribute to a positive user experience. Section 5 Metrics, Quantifying Quality Attributes. Metrics, the final piece of the FCM puzzle, provide the means to quantify and measure the criteria established for each factor. They translate abstract quality attributes into concrete, measurable values, enabling developers to track progress, identify areas for improvement, and make objective comparisons. Choosing appropriate metrics is crucial for obtaining meaningful insights into software quality. For instance, to measure the learnability criterion of usability, we might track the time it takes for new users to complete a specific task, the number of errors they make during the learning process, or their subjective rating of the software's ease of use. Similarly, to assess the efficiency criterion, we could measure the time it takes experienced users to perform a set of common tasks, or the number of steps required to complete a particular action. The choice of metrics will depend on the specific criteria being evaluated and the goals of the measurement process. By establishing clear metrics, development teams can gain valuable insights into the quality of their software and track their progress over time. Section 6. Practical Applications of the FCM Model. The FCM model's versatility shines through in its applicability across diverse software development scenarios. Let's explore a few real-world examples to illustrate its practical implementation. Imagine a team developing a mobile banking application. Security in this context is paramount. The team can leverage the FCM model to meticulously evaluate and enhance the application's security posture. They might identify factors like authentication, authorization, data protection, and privacy. For each factor, they would then define specific criteria. For instance, under authentication, criteria could include password strength requirements, two-factor authentication options, and biometric login support. To measure the effectiveness of these criteria, the team might track metrics such as the number of failed login attempts, the adoption rate of two-factor authentication, and the time taken to perform biometric verification. These examples demonstrate how the FCM model can be tailored to suit the specific needs of different software development projects. By breaking down complex quality attributes into manageable components, the model enables teams to focus their efforts, track progress, and make informed decisions to ensure the delivery of high-quality software. Section 7. FCM in Action, Evaluating Website Usability. Let's delve into a more detailed example to illustrate how the FCM model can be applied to evaluate the usability of a website. Imagine you're tasked with assessing the usability of an e-commerce website that sells clothing and accessories. Factor navigation. Criteria 1. Ease of finding products. Metric 1. Average number of clicks to reach a product page from the home page. Metric 2. Success rate of users finding a specific product using the search bar. Criteria 2. Clarity of website structure. Metric 1. Time taken for users to understand the website's hierarchy and categories. Metric 2. Number of users who successfully complete a task requiring navigation through multiple pages. Criteria 3. Mobile responsiveness. Metric 1. Page load time on mobile devices. Metric 2. User satisfaction rating of the mobile browsing experience. By collecting and analyzing data for these metrics, you can gain a comprehensive understanding of the website's usability strengths and weaknesses. Section 8. FCM and Software Security, a Powerful Alliance. The FCM model proves to be an invaluable ally when it comes to evaluating and enhancing software security. In today's digitally driven world, where data breaches and cyber attacks are becoming increasingly prevalent, ensuring the security of software applications is of paramount importance. The FCM model provides a structured framework for identifying potential vulnerabilities, assessing risks, and implementing appropriate security measures. When applying the FCM model to software security, factors might include authentication, authorization, data protection, and network security. Each of these factors represents a critical aspect of the software security posture. For each factor, specific criteria can be defined to further elaborate on the security requirements. For instance, under the authentication factor, criteria might include password complexity requirements, multi-factor authentication options, and session timeout settings. To measure the effectiveness of the implemented security measures, metrics can be defined for each criterion. Section 9. The benefits of embracing the FCM model. Adopting the FCM model as an integral part of the software development process brings forth numerous benefits, ultimately contributing to the creation of higher quality software products. One of the key advantages is its ability to provide a shared understanding of quality among all stakeholders involved in the development process. By breaking down the abstract concept of quality into concrete factors, criteria, and metrics, the FCM model ensures that everyone is on the same page regarding what constitutes a high-quality software product. This shared understanding fosters better communication and collaboration among developers, testers, project managers, and clients. It facilitates more productive discussions about quality expectations, potential risks, and areas for improvement. Moreover, the FCM model encourages a proactive approach to quality assurance by identifying potential issues early in the development lifecycle, when they are less costly and time-consuming to address. Another significant benefit of the FCM model is its ability to facilitate continuous improvement. By regularly measuring and tracking the defined metrics, development teams can gain valuable insights into the effectiveness of their processes and identify areas where adjustments are needed. Section 10, FCM, a stepping stone to continuous improvement. The journey to software excellence is an ongoing process, and the FCM model serves as a valuable compass and guide on this path. It's not a one-time evaluation tool, but rather a framework for continuous improvement, enabling teams to adapt and refine their approach as they gain a deeper understanding of their software and its users. By regularly revisiting the defined factors, criteria, and metrics, teams can track their progress over time, identify areas where they have made significant improvements, and pinpoint areas that require further attention. This iterative process of evaluation, adjustment, and re-evaluation forms the foundation of a culture of continuous improvement. The insights gained from the FCM model can be used to refine development processes, enhance testing strategies, and prioritize feature development based on their impact on overall quality. This data-driven approach ensures that resources are allocated effectively and that efforts are focused on areas where they will have the greatest impact on user satisfaction. Section 11. Conclusion: Elevating software quality with FCM. In the ever-evolving landscape of software development, where complexity continues to escalate and user expectations continue to rise, the need for a robust and adaptable quality assurance framework has never been greater. The Factor Criteria Metrics FCM model emerges as a beacon of clarity and structure, empowering development teams to navigate the multifaceted challenges of software quality with confidence and precision. By decomposing the abstract notion of quality into manageable components, factors, criteria, and metrics, the FCM model provides a practical roadmap for evaluating, measuring, and ultimately enhancing the quality of software products. It fosters a shared understanding of quality among stakeholders, promotes proactive issue identification, and facilitates continuous improvement through data-driven insights. Embracing the FCM model is not merely about adhering to a set of guidelines, it's about embracing a philosophy of excellence where quality is not an afterthought but an integral part of the software development DNA.